Good morning all. We are back with our classes. Today we will start with a new chapter which is basically from physics, which is called I and the Colourful World. I and the Colourful World. Okay? Now, according to your deleted or the revised syllabus, the portion of I is not there. So there is nothing which is there related to the I in your syllabus. As far as I know, if any school teachers, please let me know. We will do the part of the I. But generally, I is removed and all defects of I has been removed. So we have to start from refraction of light through a prism. Okay? And one copy, 1 second, please check once. This is the revised syllabus. Let me check once for the 10th. I don't think there is I, but still we will have a check through. Okay. Refraction of light through a prism, dispersion of light, scattering of light, applications in daily life. There is nothing about I and its defect. So we will not study that part. Okay. So we have our chapter starting from page number 191. Please come to page number 191. From page number 187 to 190, there is nothing, or 191 till that orange box you don't have to study. The orange box all talks about what? It talks about donation of the eye. It talks about donation of the eye if you become brain dead or if you have an accident and you become dead, then or even after you die a natural death, you should have signed or you should do that back to the society by signing your eyes. Okay, after the moment you become 18 years of age, you are an adult. On your 18th birthday or on your 21st birthday, you can make this pledge to the eye bank of the country where you can say that whenever I die, you can take back my eyes. The eyes will have many parts and that will be transplanted to 4 different people or 5 different people depending upon what they require, as there are a lot of blind children waiting to get their vision. So that part is all about eye donation. As we are not studying eye, there will be not even a question asked on eye donation. Now we will have to study for refraction of light through a prism. So first, what is a prism? Generally, prisms, glass slabs have rectangular faces. Glass slabs are rectangular with 2 parallel faces. We have studied when there is a refraction through a glass slab, a ray of light is incident. This is medium is air. This is light. When the light travels from rarer medium to denser medium, it bends towards the normal, and when it again travels from denser medium to rarer medium, it bends away from the normal. This is how refraction takes place in a glass slab. Now we have to talk about refraction taking place through a prism. Prism is a triangular surface and it has inclined faces. So let us read through it. Please open page number 191, have a pencil in hand and let us read through it. You have learned how light gets refracted through a rectangular glass slab. We have learned this. We have learned that what is this part? This is what angle? Incident angle. Incident angle is more, refraction angle is less. And in the second, the emergent angle is more. And angle I is somewhat nearly equal to angle E. You have learned how light gets refracted through a rectangular glass slab. For parallel refracting surfaces, as in the glass slab, the emergent ray is parallel to the incident ray. Correct? We have done this. We extend the incident ray backward and we say what? The emergent ray is parallel to the incident ray. However, it is slightly displaced laterally. What is this lateral displacement called as? lateral shift. We have studied this. This lateral shift is dependent on the refractive index of the glass slab. It is also dependent on the angle of incident. It is also dependent on what? Thickness of the glass slab. This is all there where you have studied refraction through a glass slab. Consider a triangular glass prism. It has two triangular bases and three rectangular lateral surfaces. These surfaces are inclined to each other. The angle between its two lateral faces, the angle between its two lateral faces is called as the angle of prism. Okay, so this is what? It is not a rectangular glass slab with parallel faces. It is a triangular prism which basically has got two inclined surfaces. The two inclined lateral surfaces make an angle between them, and this angle is called as the angle of prism. Let us now do an activity to study the refraction of light through a triangular glass prism. Very important. Activity 11.1, figure 11.4 to be drawn and shown to me tomorrow. Figure 11.4 should be drawn and shown to me tomorrow. Send pictures in your WhatsApp. So it should be done. It is very, very important. It will come. It has to come. It must come. It will come. Okay. So now what we do? See. This is my prism. Let it name it as ABC. This is called the angle of prism. Angle A is called as the angle of prism. Fine. Now what I do is I place two pins in an inclined direction in front of the prism. Okay? And I put the prism, mark it, and then circle it with pencil because I have to remove it later. And then from the other side, I see what? I see the reflection of the pin. Let it be like this. Okay? Remove the pins and then draw a line joining them. This is the line which joins them. Okay? Let us name it as P and Q. Fine? Now, the moment it meets the lateral surface of the prism, I have to draw what? A normal. Fine? Then what happens when I draw it normal? It travels like this as it has what faces? Inclined faces. It becomes straight. And then at this point, again I draw what? A normal. Correct? Then it goes back or comes out in the same way. So these are the images of P and Q as R and S. This is a normal N, or rather N dash. This is also a normal which is N dash. Fine? Which is angle of incidence now? The angle between the normal and the incident line is the angle of incidence. This becomes my angle of incidence. The angle between the normal and this angle of refraction. Prism joteli incident ಮಾಡಬೇಡಿ. Normal joteli incident angle ಆಗಬೇಕು. Okay. Now extend the incident ray forward. Correct? And extend the refracted ray backward. You get an angle which is called as the angle of deviation. It tells you how much is the prism refracting or how much angle is deviated. Did you get? So this is called as what? Angle of deviation. This is angle of prism. Understood how to do it? Once again, what I did, I took a rectangular prism, I kept two pins, thumb pins, put a kg cardboard, would keep the prism in front, put two pins, draw the point where you have put the pins. From the other side, try to see the image of those two pins. Remove all the pins and then join all the lines using a pencil and a scale. Extend the incident ray forward. Extend the refracted ray or the emergent ray backward. You get an angle. This angle is called as the angle of deviation. Clear? white paper on a drawing board using drawing pins. First step clear? Second step. Place a glass prism on it such a way that it rests on a triangular base. Trace the outline of the prism using a pencil. ಇದು ಅರ್ಥ ಆಯಿತು. ಹಿಂಗೆ ಇಡಬೇಕು prism. Okay? Draw a straight line PE inclined to one of the refracting surface, say AB. This is what we are trying to draw. PE. This is our line. Okay? PE inclined at the surface. Fix 2 pins, point P and Q on the line PE. Look for the images of the pin PQ through the other face AC. This was our face AB. Look through the image from the other side, which is face AC. Remove the pins and the glass prism. The line PE meets the boundary of the prism at point E. Similarly, join and produce the point R and S. This will meet at what? Point F. Okay. So, PQ will meet the prism at point E. RS will meet the prism at point F. Join E and F. Draw perpendiculars to the refracting surface AB and AC of the prism at point E and F. Make the angle of incidence, make the angle of refraction and make the angle of emergence. Ella angle idರಲ್ಲಿ ಮಾಡುವಾಗ ಈ angle ಇಲ್ಲ. This is the angle. Angle between the normal and the emergent ray. Prism ಜೊತೆ ಮಾಡಬೇಡಿ. This is not the angle. The angle is between the normal and the incident ray. Okay? Here PE is the incident ray, EF is the refracted ray and FS is the emergent ray. Nodಕೊಳ್ಳಿ. PE is the incident ray, EF is the refracted ray and FS is what ray? Emergent ray. You may note that the ray of light is entering from air to glass at first surface AB. The light ray on refraction has bent towards the normal. At the second surface AC, the light ray has entered from glass to air, hence it is bent away from the normal. Compare the angle of incidence and angle of refraction at each refracting surface of the prism. Is it similar to the kind of bending that occurs across a glass slab? Similar but not identical. Okay. The peculiar shape of the prism makes the emergent ray bend at an angle to the direction of the incident ray. This is the direction of the incident ray. It bends towards the direction of the incident ray. This angle is called as the angle of deviation. In this case, angle D is the angle of deviation. Mark the angle of deviation in the above activity and measure it. How do you get an angle D? Extend the incident ray forward. Extend the emergent ray backward. The angle which it makes is called as the angle of deviation. Angle A is called as the angle of prism. Clear? Understood refraction through a prism? Please write a question. Please write a question. Explain with the help of an activity. Explain with the help of an activity refraction of light. Explain with the help of an activity refraction of light through a glass prism. Refraction of light through a glass prism. You have to write the activity in your own words, okay, and then draw the diagram, mark it as it is given in the textbook and then show it to me, okay. So, and one more thing, at the end please write how do you define angle of deviation. Next question, very how do you define the angle of deviation? What will you write? It is the angle which is formed, it is the angle which is formed by producing the incident ray forward, and the emergent ray backward. Fine? Right, next point in that, it depends on the angle of prism. It depends on the angle of prism. Okay, so how is this dependent on angle of prism? Kindly look here. Angle of deviation is equal to angle of incidence plus angle of emergence minus angle of prism. Formula barkodi. Angle of deviation is equal to angle of incidence plus angle of emergence minus angle of prism. Fine? When a ray of light passes through the prism, it always bends towards the thicker end of the prism, not towards the thinner end of the prism. Okay, so it will always come down. Clear? So this is how it is exactly similar to the way it works in glass slab, but there is no shifting of the incident ray. There the incident ray becomes parallel to emergent ray, but it shifts backward. Here it bends in the direction of the incident ray because it has two inclined faces. There it had two parallel faces. Here it has two inclined faces. Clear? The angle of deviation basically tells you how much it gets deviated towards the incident ray. So this is dependent on the angle of prism, on the thickness of the prism. Okay, so how do you find out? Angle of deviation is equal to angle of incidence plus angle of emergence minus angle of prism. Most of the time the prism which we use in lab are all having an angle of prism as 60 degree because we generally use an equilateral prism. Okay, clear till here? Now write heading dispersion of light by a glass prism. This was what? Refraction of light by a glass prism. Heading barkodi, heading mane hogbariri because you have to do lot of diagrams today. Okay, so next is what? Dispersion of light by a glass prism. Dispersion of light by a glass prism. Please remember and don't get confused. Dispersion is different, refraction is different. Dispersion of light by a glass prism. So this is dispersion of light by a glass prism. In few schools who started with light, your first term portion will include light and dispersion of light, but your second term portion will include electricity and magnetic effect of current. It was said till last week that there were chances of opening the school by September, but of late I think the central government has told most of the states not to open the school by December. Okay, so I don't think your schools are going to start anytime soon. So it is better that we finish our portions. You have to write a half yearly. So we will see how it can be done, as every school is conducting their own exams and I don't want to trouble your school exams as those marks count more. You can listen to the classes and read through. If you have doubts, you can call me back. But the amount of call I get sometimes are for weird reasons, not for the actual reason of studies. So please make sure that if you have real doubts, call me, I can help you out. But this time the paper what we write has to be dropped back at home so that we can correct and see how well you write. Okay? I will tell you the date somewhere in September, maybe around 11th, 12th, somewhere around that time we will have a class, we will have a test. Let us see how everybody's school timetables are there for the first test, and then we will check out with us. Okay? Back to dispersion of light. What does dispersion mean? Okay, refraction means bending of light. When light travels from one medium to another medium. What is dispersion? When a white light passes through a prism, it splits into 7 different colors. What are the colors of the rainbow? The same colors. What are the colors of the rainbow are? Pure. Don't we study like this? What is pure? It is violet, indigo, blue, green, yellow, orange and red. These are the colors of rainbow. So what is dispersion of light? When a white light passes through the prism, it basically splits into 7 different colors. This band of 7 different colors is called as spectrum. The spectrum of light. Okay, it is studied, the spectrum itself is studied under a separate branch of physics called spectroscopy. Okay, so when a white light or even sunlight is passed through a prism, it splits into 7 different colors. This phenomena is called as dispersion of light, and a band of 7 colors which is obtained is called as what? Spectrum. Clear? So if I pass through a prism, a light, it splits into, this is my screen, it splits into 7 different colors. What are the colors? From where should I start? Blue below or red? It is always blue below and red on the top. Violet below and red on the top. Why is this exactly like this? This basically is like this because dispersion depends on the wavelength of light. What it depends on? Wavelength of sound or wavelength. What is wavelength? The distance between 2 consecutive crests or 2 consecutive trough is called as wavelength. It is always denoted as lambda, a Greek letter lambda. Okay, so it is always dependent on what? Wavelength of light. Fine. Blue has or violet has shortest wavelength. Violet has shortest wavelength and scatters the most. Red has longest wavelength and scatters the least. If concept clear, it will go. Okay, violet has shortest wavelength, scatters most and bends the most. That is why you will find violet is at the base. Red has longest wavelength, scatters the least and bends also the least. Clear? So why does dispersion take place? It takes place because every color has got a different wavelength. Okay, and due to it, it bends differently when passed through a glass prism. So always when you pass it through a glass prism, you should use 7 different color pencils. You all will have color pencils, so fight with your younger ones and get if you don't have. So you should have what colors? All the 7 colors of violet, indigo, blue, green, yellow, orange and red. The topmost part will be what? Red. The lowermost part will be what? Violet. Okay? Never make it ulta. Why? Because violet has the shortest wavelength. It scatters the most and bends the most. Red has the longest wavelength, scatters least and bends least. Clear? Understood dispersion of light? So when white light is passed through a glass prism, it splits into 7 different colors. This happens because each color of light or each small component of light has got different wavelength. As they have different wavelength, they bend differently. Is it clear? Okay. Now when I know that white light is made up of 7 different colors, do every day I see 7 different colors? No. So the same logic works that if white light is made up of 7 different colors, if I mix 7 different colors, I will always get what? White light. So what Newton did an experiment to prove is that light is made up of 7 different colors. He took a prism which is upright. Upright and then straight line into it. Okay, and he passed white light through it. As usual, it split into 7 different colors. And something like this. Okay, and then we put another prism which is ulta, which is inverted. We put what? Another prism which is inverted. This is called as dispersive prism. This is called as recombinant prism. Then what happened? These colors, when passed through this, it joined together to form what light? White light. This shows that white light is made up of 7 different colors and 7 different colors combined together to form white light. This is called as Newton's experiment to prove that light is made up of 7 different colors. Okay, so let us read through it. Diagram 11.5 important. Diagram 11.6 important. 11.5, 11.6, 11.5 to be used color pencils. Okay, don't use sketch pens or any other things. Use normal color pencils which you had. What were they called? Crayons, no? Illappa, crayons illa normal color pencil baruttalla. You must have seen and appreciated the spectacular colors of the rainbow. It is something a normal human instinct. As we hear the plane, we just lift our head and check. Same way when a rainbow comes and how much old you are, you feel happy to see a rainbow. Okay? How could the white light of the sun give us various colors of the rainbow? Now if you go and see all your falls also, wherever it is falling, you will find a rainbow being made because of the white light. Okay? Before we take up this question, we shall first go back to refraction of light through the prism. The inclined refracting surfaces of the prism show exciting phenomena. Let us find out through the activity. Take a thick sheet of cardboard and make a small hole or a narrow slit in its middle. Why we are doing that? So that we get concentrated light rays. Okay? Allow sunlight to fall through the narrow slit. This gives a narrow beam of white light. Now take a glass prism and allow the light from the slit to fall on one of its faces. So sunlight is allowed. Turn the prism slowly until the light that comes on it appears on a nearby screen. What do you observe? You will find a beautiful band of colors. Why does this happen? The prism has probably split the incident white light into band of colors. Note the colors that appear at the two ends of the color band. What is the sequence of color that you see on the screen? The various seen colors are violet, indigo, blue, green, yellow, orange and red. The acronym VIPCURE will help you to remember the sequence of colors. Please underline. The band of colored components of the light beam is called its spectrum. You might not be able to see all the colors separately, yet something makes each color distinct from the other. Underline again. The splitting of light into its component colors is called dispersion. The splitting of light into its component colors is called dispersion. Please write. Define dispersion. Define dispersion. First question. Second question. define spectrum. Define dispersion and define spectrum. Define dispersion and define spectrum. So what is dispersion? The splitting up of white light into its constituent 7 colors is called as dispersion of light. The band of 7 colors which you obtain after the light is split when passed through a glass prism is called as what? Spectrum. Please write, why does light, or what is the cause of dispersion? What is the cause of dispersion? Okay, so the answer for it, you have seen that white light is dispersed into 7 color components by a prism. Why do we get these colors? Please underline from here. Different colors of light. Can you see that line? Different colors of light bend through different angles with respect to incident ray as they pass through the prism. The red light bends the least while the violet the most. Thus the ray of each color emerge out in different path and thus become distinct. It is the band of distinct colors that we see in a spectrum. I'll barcode the answer as different colors of light bend through different angles with respect to the incident ray as they have different wavelength. I'll add ಮಾಡ್ಕೊಂಡ್ಬಿಡಿ. Different colors of light bend through different angles with respect to the incident ray as they have different wavelength. As they have different wavelength. Clear? So which has the longest wavelength will bend the least. Which has the shortest wavelength will bend the most. Idil barcode. What does it mean? Violet, shortest wavelength, scatters most, bends most. Red, longest wavelength, scatters least, bends least. Full ಜ್ಞಾಪಕ ಇರುತ್ತರ ಬರ್ಕೋ ಇಲ್ದಿದ್ರೆ. It is what? Violet has the shortest wavelength, scatters most and bends the most. Red has longest wavelength, scatters least and bends least. So all 3 questions clear. Dispersion of light when white light is passed through a glass prism, it splits into its 7 constituent colors and this is called as the dispersion of light. The band of colors which is obtained on the screen is called as its spectrum. The reason for dispersion of light is that each color of light has a different wavelength. This different wavelength makes the light bend differently. Okay? Now please write above figure 11.6. Prove that white light is made up of 7 different colors. Prove that white light is made up of 7 different colors and 7 different colors combine together to form white light. And 7 different colors combine together to form white light. ಅರ್ಥ ಆಯ್ತಾ ಏನು ಹೇಳ್ತಾ ಇದ್ದೀವಿ? That white light is made up of Vibgyor, 7 colors and the 7 colors together will again join and form what? White light. So this is the experiment of Newton. So the same question can be asked as explain Newton's experiment on white light. Same question can be asked as explain Newton's experiment of white light. ಇದನ್ನ ನೀವು ಸ್ಕೂಲಲ್ಲಿ ಡಿಸ್ಕ್ ತರ ಮಾಡಿರ್ತೀರ. ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಿಸಿಲ್ವಾ 7th 8th ಅಲ್ಲಿ ಯಾವಾಗ ಫಸ್ಟ್ ಟೈಮ್ ಲೈಟ್ ಹೋದ್ರಿ A small thermocol round is cut, a disc is cut, and it is painted into 7 different colors, and it is mounted on a needle, and the needle is then connected to a motor. When it is rotated at a high speed, you will see what color of disc? White color of disc, because 7 different colors combine together to form what light? White light. Okay. Isaac Newton was the first to use a glass prism to obtain the spectrum of light. He tried even one mark question, objective type question, barcode, that line. He was the first to obtain the spectrum of sunlight. He tried to split the colors of the spectrum of white light further by using another similar prism. However, he could not get more colors. He then placed the second identical prism in an inverted position with respect to the first prism, and allowed all the colors of the spectrum to pass through the second prism. He found a beam of white light emerging from the other side of the second prism. This observation gave Newton the idea the sunlight is made up of 7 colors, and 7 colors again combine together to form what? White light. Any light that gives a spectrum similar to that of sunlight is often referred as white light. Anything which gives you the same 7 different colors when passed through a prism, it will be called as what light? White light. Okay. Now figure 11.8. Very important. 3-mark question in bold. Please write the question. Explain the optical phenomena associated with the formation of rainbow. Or explain the phenomena associated with the formation of rainbow. Right? So all of us have seen rainbow. Rainbow generally happens when there is a heavy shower and suddenly there is appearance of sunlight. So there is enough amount of tiny droplets of water in the atmosphere. Most of the time we see rainbow not on a sunny dry day. We see rainbow when there is enough water content in the atmosphere. Okay. So most of the time rainbow is seen when you have a heavy shower and suddenly what happens? The sun reappears. So there is enough amount of water droplets in the atmosphere which act as tiny prisms and they disperse light. First logic. So rainbow basic phenomena is what? Dispersion of light. Okay, uske pehle. Have you seen that rainbow is always formed opposite to the sun? And rainbow is never a complete circle because we are not standing at the pole and seeing the rainbow. We are at some part in the earth, so we only see what? A semicircle of the rainbow. Okay? So first thing, rainbow is always formed opposite to the sun. It should have lot of water content in the atmosphere as the tiny droplets of water act as prisms. Okay, now what exactly happens within that water droplet? So what are the optical phenomena that is associated with rainbow? So let us consider a water droplet like this. So if this is our water droplet, you will find that the light enters the water droplet from air. So this is air, this is water. So what takes place first? Air to water, refraction. After refraction, the light gets dispersed into 7 different colors. So there is what of light? Dispersion of light. Okay. Then from there it gets totally internally reflected. It is bent into such an angle that it cannot pass out. It again comes back and hits the other surface. This phenomena is called as TIR, total internal reflection. It gets reflected within and then it again undergoes what? Refraction. It will come like this and it will finally join together to form white light. Okay, so once again I will explain what are the phenomena associated with rainbow. First, when you take a water droplet, first it is what? Refraction. Fine. Then it disperses into 7 different colors. Okay, so this is what? Dispersion. Then both these together basically will join to form what? Total internal reflection. And then it again comes back as what? Refraction. So what are the optical phenomena associated with rainbow? Refraction, dispersion, total internal reflection, and then refraction again. Rainbow is always formed opposite to the sun. Rainbow is formed when there is enough amount of water droplets present in the atmosphere, as these tiny water droplets act as prisms. When the light enters or the sunlight enters the water droplet, first what takes place? Refraction. Then what takes place? Dispersion. Then what takes place? Total internal reflection. And then again refraction. Clear? Understood? So the optical phenomena associated with rainbow formation is refraction, dispersion, total internal reflection, and again refraction. So let us read through it. A rainbow is a natural spectrum appearing in the sky after a rain shower. It is caused by dispersion of sunlight by tiny water droplets present in the atmosphere. A rainbow is always formed in the direction opposite to that of the sun. The water droplets act like glass prisms. They refract and disperse the incident sunlight, reflect it internally, and finally refract it again when it comes out to the raindrop. Correct? First it refracts, then it disperses, then there is total internal reflection, and then again refraction. You can also see a rainbow on a sunny day when you look at the sky through a waterfall or through a water fountain with the sun behind you. Please write. Name 3 conditions where you can spot a rainbow. Name 3 conditions where you can spot a rainbow. You can spot a rainbow in the sky, through a waterfall or through a water fountain. Done? So we will study only till here today. The reason is it's a very small chapter and I don't want to bombard you with things. So I need tomorrow, how many figures? 4 figures drawn. Okay? I will send you the notes, but I will expect you to draw these 4 figures neatly and mark them. Okay? Thank you.